types. They are point defects and line defects. Point defects are due to deviation around a point or an atom in a crystal. Line defects are due to deviation in the entire rows of lattice points. 1. Point defects. Point defects, impurity, non-stoichiometric, and stoichiometric defects. A. Impurity defect. This defect is due to the impurity in the crystal. For example, in molten NaCl, if SrCl2 is present, then some of the Na plus ions are occupied by Sr plus 2. Each Sr plus 2 replaces 2 Na plus ions. One of the sites is occupied and the other remains vacant. The vacancies are equal to number of Sr plus 2 ions. Another example is solid solution of Cl2 chlorine and AgCl silver chloride. B. Non-stoichiometric defect. These are two types, metal excess defect and metal deficiency defect. Metal excess defect due to an ionic vacancy. It is due to the absence of anion from lattice site, leaving a hole which is occupied by electron to maintain electrical neutrality. The anionic sites occupied by unpaired electrons are called F-centers. German word Farbecenters means color center. More number of F-centers, more will be the intensity of color. NaCl, sodium chloride, is an yellow. LiCl, lithium chloride, is pink. Metal excess defect due to presence of extra cation and interstitial sites. Example, ZnO, zinc oxide. This is due to the movement of metal ions to interstitial sites and the electrons to neighboring interstitial sites. Example, ZnO, zinc oxide, is white when cold and yellow when hot because it loses oxygen and Zn plus 2 ions occupy the interstitial sites. Metal deficiency defect. Example, FeO, ferrous oxide. This is due to absence of a metal ion from its lattice site and charge is balanced by ion having higher positive charge. Generally, transition elements exhibit this defect. FeO, ferrous oxide, is mostly found with a composition of Fe0.960. It may range from Fe0.930 to Fe0.960. Stoichiometric defects. Vacancy defects and interstitial defect. These do not affect the stoichiometry of solids. These are called intrinsic or thermodynamic defects. It is of two types, A. Vacancy and B. Interstitial defects. Vacancy and interstitial defects are shown by non-ionic solids. Vacancy defect. When some of the lattice sites are vacant, it exhibits vacancy defect. This results in decrease in density of the substance. Interstitial defects. When some of the constituent particles occupy an interstitial site, it exhibits interstitial defect. This results in increase in the density of the substance. Ionic solids have to maintain electrical neutrality, so they exhibit Frankel and Schottky defects. Frankel defect. This is observed when the smaller ion, cation, is dissociated from its normal site and occupy interstitial site. This does not change the density of the substance. This is shown by ionic solids where there is large difference in the size of ions and low coordination number 4 to 6. Example, ZnS, zinc sulfide, AgCl, silver chloride, silver iodide, AgBr, silver bromide. Schottky defect.